All right. Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining to GraphAcademy Live, not Neo4j Live, but a new format we're trying out today. GraphAcademy Live, importing CSV data, which is one of the many graph learning courses that is available on our free online learning platform that is GraphAcademy. And I have with me today Martin O'Hanlon, who is working at Neo4j with the developer relations team and specifically on courses like importing CSV data, but also many others. And he's our educational, what's your title exactly, Martin? Educational program
I think my
guru of learning.
thank you, Alex. I think my actual title is technical curriculum developer.
Okay.
But yes, my almost all of my job here at Neo4j is in creating educational materials, including courses for GraphAcademy.
Yeah, yeah, that's very cool. It's a very cool job actually. If we have time, maybe you can talk a little bit about how you came to that. If we have time for a detour, but let's maybe save that for later. But for now, yeah, this is. I don't know when did we talk? I think at the end of last year we talked about what can we do new, what new things do we want to try, what's in store on the live stream part of it, and then Martin and I we discussed a few things and came up. Hey, there are so many GraphAcademy courses, so many things, so many ways people learn, and they are great. They have interesting topics and good themes and various steps on your way. So this today is more of a beginner's segment, but there is more advanced stuff. There is stuff on LLM, there's stuff on data science, stuff on various programming languages, from Python to JavaScript and all that stuff, and Neo4j specific ones, data modeling, Cypher fundamentals, and so on. And we thought, okay, how can we make this, encourage people to try it out? How can we help people who are struggling with it a little bit? Maybe how can we do something like that? And we came up with this format, which is like we pick a course, we start with it, we go a little bit into the session, but we also encourage people to ask questions, so we can answer your questions and see how you feel, what's your take on the courses, what you know maybe you're struggling with something, maybe something is unclear, then we get, obviously that's also helpful for us so we can improve it in the future, and then we can show you a little bit about how it's gone, and then you can continue on your own, and we kind of like help you get started. It's kind of like a little bit of the idea.
Yeah, and more generally, I think learning as a group is more fun than learning on your own.
Yes.
Yeah.
Yeah.
So I mean, I'm ready to get started. Should we just go straight into it, Alex? What do you think?
Yeah, let's do that, and then we can always take a break and do look at questions. I have always an open eye on it, so I see a couple of people have already mentioned that they did some of the GraphAcademy courses. Somebody here said they're stuck on adding movie notes in the steps, so I guess we're getting to that later on.
Yeah, I'm pretty hopeful. I mean, it's unlikely, the time we've got, we'll get through the whole of the course. But hopefully, we'll certainly get up to creating nodes and relationships. Yeah, we'll certainly get past that part.
Yeah, sounds good. Cool. I can put your screen up.
Cool.
Here we go.
Great, thank you. So you're going to have to excuse me because I've got like two screens. So my eyes do this. It's just me checking up on what I'm doing, just kind of making sure that I've got everything in the right place. But hopefully you can see GraphAcademy. So GraphAcademy is Neo4j's learning platform, free online courses and certification. You don't need anything for the vast majority to do of our courses than just GraphAcademy. And you log in, you sign in. This is what it looks like, and it'll tell you your current courses. And the course that we're going to be looking at today is called Importing CSV Data into Neo4j, and it's the fourth and last course in our kind of fundamentals or sort of beginners getting started with Neo4j set of courses. So first thing we have to do is we have to enroll in the course. So every course has got a small description where you can learn a little bit about that course and tell you kind of the learning objectives and what you'll have to kind of commit, but also kind of what you'll need as well. So yeah, let's just get into it, and we're going to enroll on the course, and we'll start kind of working our way through. And kind of what I hope we can do is kind of talk about, or certainly what I'm going to do is I'm going to talk a little bit about the content of the course, and maybe some of the gotchas that you might, or the kind of challenges that you might reach. But we're going to do it together. And do you know what? If you want to kind of log into graphacademy.neo4j.com, enroll in the course, do it together, that's great as well. If you just want to watch along, you do you. So let's get started. So like first off, in this course, this course is all about importing data, CSV data, and creating a graph database. And the graph database we're going to create is a kind of classic Neo4j graph databases, which has got movies and people and kind of relationships between those. And we're going to create and we're going to build an import process using Cypher. And that's going to create the nodes, relationships, and properties. We don't need anything else. One of the things that almost all GraphAcademy courses come with is a Neo4j sandbox. So this is a Neo4j instance that you can use. And if you click on the little toggle sandbox button at the bottom, you can bring it up. Lessons where we expect you to use the sandbox, it'll automatically appear anyway. So here we go. Right. Yeah, I've kind of read about what I'm going to be doing. I know how to find my sandbox, and I'm kind of ready to go. So a lot of GraphAcademy courses have, GraphAcademy lessons have both videos and transcripts. This is already a video. So what I'm going to do is I'm going to use the transcript. The transcript is just the written version of the video. And really the choice is yours in terms of whether you prefer video content or kind of written transcript content. But yeah, wherever I see a video in this, I'm just going to flick over to the transcript. So when we think about the data import process, we typically start with a set of source files. You know, these could be come from a whole host of different systems, and you know, we're talking about CSV files, and a lot of what we're going to do in this course is actually kind of like load, parse, and kind of import data from CSV files. And the reason we've picked CSV for this particular course is it's obviously a really common data format for data exchange, and you know, the vast majority of data tools will output a CSV file. The kind of important thing that I wanted to kind of like just sort of bring out in this point is that, and there is a sort of misconception about this, which is before you import any data into Neo4j, there is no graph and there is no data model. As you import data, you create the graph, and in doing so, you create the data model. And kind of like before you start the import process, it's kind of important that you understand the data in your source files, that you inspect it and you clean it, and also understand the graph data model that you're going to be implementing during the import. I'm a big fan of iteration, so you know, have an idea in terms of, you know, actually what I think the data model is going to look like, but don't be afraid to iterate on it. But yeah, the process is going to involve creating some Cypher code to read the source data, transform it as required, and then create the nodes, relationships, and properties to create that graph. And most lessons within GraphAcademy have a kind of check your understanding, a little simple quiz question, and this one's no different. So true or false, data structure for your graph exists in Neo4j before you import data. As we kind of talked about, it doesn't, right? Before you create any data, it doesn't exist, and that's a really important thing to recognize. And we can check our answer, and hopefully we've got it right. There will be some that I get wrong. I'm absolutely convinced of it. So before we start, you know, the kind of process, let's talk about CSV files. I'm sure you guys are all kind of are, you know, data experts, but not everybody that does our courses is, and it's really important that we all start with the same base understanding. So actually this lesson is just a little bit about understanding CSV files, but there is some important points that we need to kind of make note of before we start to use Cypher to import it. So the first one is field terminators. CSV files don't have to just use commas to separate fields, as this one does. They can use virtually any character. This example here, I've expressed the same data using a pipe. And we need to know what field terminator is used within our CSV file when we're going to import it. It's also really important to note, does the CSV file have headers or not? Again, not all CSV files will have headers, but again, it's important to know that. And just a kind of note about quotes as well. Again, most data applications will automatically kind of quote data, and will give you an option and kind of field terminators. And there's also some information within the course about that difference between normalized data and denormalized data, whereby the example that I've picked out is in normalized data you may have a different file per entity, whereas in denormalized data you may have one file that's just got all the data, potentially with duplicated data in it as well. I think what I'm saying is it's really important that we understand our data. We understand in terms of our CSV data, how it's structured, what field terminators have been used, and whether it's got headers. And again, simple question. So, which of the following statements are true about CSV files? Well, a comma has to be used. That's not true. Headers are indeed optional, and CSV files can represent normalized and denormalized data. I've just realized I can't see people's comments. I'm just going to, should we? That's right. So I'm just nipping back to just to check to see if there's any comments.
So far, no comments. The only comments that was, and I find it kind of funny, maybe I read it out now, is from Dax Dev.
Okay.
They write, we should stop using CSV altogether. I mean,
yeah, it's the it kind of represents the dream. And one of the things we'll talk about is, or hopefully is about other import processes and about other considerations. And that's kind of the last module in the course. I'm not sure we'll get to it, but I don't think we should fall too heavily on CSV. If you have a requirement to import data and the only data you can get it out is in a simple text format, then sometimes you don't have a choice.
Yeah, that's true. Unfortunately, yes.
Yeah. Anyway, so let's. CSV is horrible, but fantastic format. It works quite good, actually.
Yeah, that's true.
Yeah. I just can have a quick drink.
Yeah, but this is not, like you just said, maybe just to reiterate again, is important that this is not the only way of loading data into Neo4j. This is not the exclusive way of doing, even with CSV. There's other ways of doing it, but it's an easy way. And I guess especially with many people, if you want to migrate or you want to try out at least how this graph thing works for you, getting a data set in a CSV format is probably one of the easiest ways of getting your hands on it. So that's why we show it here.
Yeah, exactly. Okay, so I've just kind of moved on to the next lesson, and this is where we're gonna start to kind of write some Cypher. So we're going to use the load CSV Cypher clause to kind of open a file and essentially output it using Cypher. Now, load CSV clause looks a little bit like this in terms of its syntax. We use load CSV. We can optionally say whether that file includes headers or not. We need to give it a URL, and there are lots of differences in terms of what your implementation of Neo4j looks like. But I'm going to be using like a public URL just to kind of download a CSV file. And I can also specify optionally what the kind of field terminator is. So I'm going to write some Cypher to load a very, very small CSV file. It's this CSV file that's got a header. Commas are used as the field terminator. And do you know what? Let's have a look at it. We might as well. I'm hoping this is going to fire up VS Code. Yeah. Why can't I zoom in? There we go. Yeah, so we can see that this file contains, a relatively small CSV file of just 3 rows with some headers, and a comma is used as the as the field terminator. So in Sandbox, run the following Cypher statement to load the people.csv file. And actually, I'm not going to make you copy that out of there to run it in the Sandbox every time. The Sandbox is opened automatically, and it's kind of pre-populated the Cypher query. So we can give it a run. Again, we can see it's going to load the CSV. We can see it's got headers. It's going to, from this URL, we're going to give it the alias of row, and we're going to return that row. So we run it, and we can see that we get the data back that we were expecting. There's a couple of really interesting things to note. So we get JSON data back, and that the headers have been used as field names, and indeed we get the kind of data back. Now, obviously, the field terminator wasn't specified because the default is comma. But again, had it been something different, we could have added field terminator and given any character we wanted. I don't know, maybe it's a UK pound sign. Who knows? Yeah. But again, because it's commas, we don't need to do it. I kind of like a really good simple check just when you're kind of loading data is just to do a count. Just sort of say, does the number of rows that exist within the CSV file match what I'm actually loading in? So there's a point about accessing files. So load CSV files can access files on Neo4j's file system or a remote machine. We are using this Sandbox. If you're using AuraDB, you can only access remote files. And there's a whole host of kind of like different options in terms of how you do it. So that is the kind of load CSV clause that we're going to use in Cypher to get data into Neo4j. And again, we have some questions. So to check our understanding. So which of the following are valid load CSV files? So from load CSV from file as line. That kind of looks all right to me. Load CSV including headers from file. Now, hang on. With headers. So yeah, I think somebody's trying to trip me up there. Load CSV from with field terminator. And again, that one looks all right to me. There you go. I've learned something on my route, on my way. Now, one of the things that we like to do in GraphAcademy is provide some optional challenges. These are ways, if you want to, you can kind of stretch your own learning. And this optional challenge is about just saying, okay, well, I've given you a CSV file. One of the challenges is actually getting a file somewhere where Neo4j can access it, and also giving you the opportunity to maybe export a CSV file from your own data application. So what I have done here, what this challenge is all about, is basically saying, find a CSV file, upload it somewhere where you can access it, and then write a simple load CSV statement to import it. Now, I previously have put a CSV file into Google Drive. So I will quickly show you what that looks like. So I'm going to say load CSV with headers. The file that I've got has definitely got headers. Oops. I'm sorry, I'm just going to copy the URL because that's far too long to write in. So I'm going to say load CSV with headers from this URL. It's a CSV file on Google Drive. I'm going to say as row, and then I'm going to return each row. And this looks like quite oh, here we go. And this is actually a CSV file of emojis. I have no idea where I found it, but CSV file of emojis that I found. But again, these kind of optional challenges are a nice way to kind of stretch your own learning and kind of like give yourself the opportunity to put what you've learned into your context. In this case, being a file that you have found yourself and hosted yourself. So that is like the end of module 1, and we're going to kind of move into module 2. So we have looked at what CSV files are, why they're useful. We've spoken on this call a little bit about why they're challenging, and we've also used load CSV to actually get that file and get it into Neo4j. So now what we're going to do is we're going to advance to the next module, which is about creating nodes, properties, and relationships. So again, new module. What we're going to do in this module is we're going to create some nodes and relationships with data from a CSV file. We're going to assign some properties to nodes and relationships, and we're also going to look at the importance of things like a unique ID, IDs, and how we might create constraints to ensure that they are unique as well. So again, as we spoke about right at the start, this is when we're going to take some data about movies and about people related to movies and kind of create nodes. So, oh, hang on, let's go to the transcript again. So what we're going to do is we're going to use the merge Cypher clause to create nodes, basically using data within a CSV file. So we're going to load a CSV file of person data into person nodes in Neo4j. So the CSV file contains these fields, and let's go and have a look at it. So we can download it, and if we open it, oh, that's not particularly well formatted. And very, very zoomed in. Zoom out a little bit. Okay, so we can see that a CSV file has got a collection of fields. It's got an ID, person TMDB ID. It's got a bio about that person. It's got the date they were born, where they were born, and various other bits and bobs, including their name. So this person was Harrison Ford. So that's our first job, is to load that data into Neo4j. So we're going to follow these instructions and inspect the content. So we're going to download it and we're going to open it, which we've just done. Had a look at it. That's good. You may not have noticed, but it should see that the file contains headers. It does, and that the field delimiter is a comma. I have, which we can see if we look at the kind of raw file it is, which is good. Now we know how to kind of load this thing in. So we can run the following Cypher statement to load the CSV file and return the contents. Why not? So let's do that. So if we run it, we can see, yeah, load CSV from this URL as row, as we've seen before, and we get a load of data back. That's good. We've got data into Neo4j. So now what we need to do is, once we've got the data into Neo4j, we need to create some nodes. And this is what this Cypher clause does. So we can see that it loads the CSV with headers from that URL. And we are using the merge clause and set to create the data. So merge will create a node if that node doesn't already exist. So in this case, it's going to create a node with the label person, and it's going to set an ID, or the TMDB ID, which I think stands for the movie database ID, which is where we originally got this data from. And it's going to set that ID to be the value that we get from the person underscore TMDB field within this CSV file. In this case, it's actually using the toInteger function to convert that to an integer. And it's also setting a number of properties. So what I like to do is kind of pose a number of questions. So let's just test our learning. So where does the CSV data come from? Well, we can see it comes from this URL. What does merge clause do? Again, we've talked about that. It creates a node if one doesn't already exist. Okay, so what variable holds the data from the CSV file? Well, in this case, it's called row, because when we imported the data, we said as row. Sorry, this is slightly zoomed out, so it's slightly difficult to see. That's better. Where are the properties set? Well, we can see that the properties are set as part of the set command. And why is the toInteger function used? Well, it's used because TMDB ID is a number. So, a lot of talk, a lot of reviewing code. Let's run this Cypher and have a look. So let's run this Cypher. Okay, we have run it, and we can see that 444 labels, 444 nodes, 3,096 properties have been created. So that kind of looks like it's done what it should do. So, and we can confirm that just by running a simple match clause that will return us the first 25. The first 25 nodes. And here we go. So we match person, return P, limit 25, and here we go. We've got Jim Carrey, we've got Richard Harris, and we can see that not only do we have these people, but they have data that matches what we're expecting from that CSV file. So what we've done is we have loaded a CSV file that we looked at that had loaded person data in it, and we have checked the results to actually say, okay, actually looks correct. In a later lesson, what we're going to do is we're going to use what we've seen here, and we're going to modify it to add movie nodes, which I think is one of the queries we had. Okay, cool. So, and again, let's check our understanding. Select the correct Cypher statement to create a node from data within the database. Okay, well, so this is load CSV with headers from a file called games.csv as record. So it's going to have to be that one because we're using record.title, and that's the only thing that's different. Yeah. Nice. Cool. So we have done that first step, that first step, and we've kind of seen how you would load data. Other thing to talk about is unique IDs and constraints. So it's a best practice to have an ID as a unique property value for each node. You know, I don't wish to explain in too greater detail why unique IDs are a good idea, but you know, they help us ensure that duplicate data is not created, and also give us a kind of a key to reference as well. So this is the syntax for creating unique IDs on a property. So we use create constraint, we give it a name. We can optionally say if not exists. So if it does exist, it won't try and create it. We say, okay, well, for what label name it is it, and for what property name should be unique for each node of that label. So the person nodes that we just created all have a unique TMDB ID, and we can create a constraint for the TMDB property for all those person nodes by using this cipher. So yeah, we can see that the constraint name is person_TMDB ID. We can call it whatever we want. We're using the optional if not exists, and it applies this to all nodes with a person label. So let's go ahead and run it. And we can create that constraint. We've added one constraint, and we can check to make sure that there is actually a constraint in the database by doing show constraints. Again, we can see it. That's great. Always good idea to test. Let's test to make sure that if we try and create a person node with an ID that already exists, I know 3 already exist in here. It chucks us an error and says you can't do that. And again, we can drop a constraint if we need to. So true or false, Neo4j will allow you to create duplicate unique ID constraints. That is definitely false. It will not let you do that. Great. So what we've done in terms of creating nodes is actually we've spent quite a lot of time looking at code, yeah, and reviewing and learning about how it works. Our job now is to advance on to adding the movie nodes as part of this database. Before I move on, is there any questions? Anybody? I get this error when I try and add movie nodes. Cannot merge the following node because of null property value. Okay, Peter, let's run through the exercise. I don't know. I kind of have a feeling that the reason I'd like to see a cipher, but I suspect the reason you're getting it is that for whatever reason, you've got a null in your data, which seems unusual. Anyway, okay. Let's review, and then we can take a little bit of time just to kind of look at it. So anyway, to complete this challenge, you are going to need to review the movies.csv file and the data it contains. We're going to have to create a constraint to ensure that there are no duplicate movies. And we're going to have to construct a Cypher statement to load the CSV file and create the movie nodes. So if we open up this CSV file, again, let's just have a look at it. We can see that there is if I use a little edit CSV, it makes it a little bit easier to read. We can see we have movie IDs, we have titles, we have budgets, countries, all sorts of fields, interesting fields about movies. We can see that there's headers, and if we look at the raw source data file again, we can see that a comma is the field terminator. Pretty normal stuff, in the same as what we've seen previously. So GraphAcademy has given us a little starting point. We're actually saying here's the URL that we can load. I'm sort of tempted let's just run that and see whether, okay, great. So we get data back. That's good. We've kind of proved that we can read our CSV file, and we can prove that it's got data in it as well. So let's create the constraint first of all. So the movie ID field is unique for every movie, and we should create a constraint to ensure that that property is always unique for every movie node. So GraphAcademy sort of said, well, we always like to copy code. So it's given us the code that we use to create the person constraint. So actually, I'm going to start with that because, really what I need to change here is, first of all, I need to, I don't want to call it person underscore TMID. I want to call it movie underscore movie ID. It's not against the person nodes, it's against movie nodes to ensure that movie ID. So I'm going to require movie ID is unique. That looks good to me. I'm going to run that. I've added a constraint. Oh, do you know what? If I do show constraints, we can have a look. All right, yeah, great. Now I've got two. I've got the movie one, and I've got the person one that we created earlier. Great. That's good. Right, I'm pretty confident that Cypher has created the constraint that I needed. So now I need to head on to loading in the data from the movies.csv file. So our instructions are load the movies.csv file from this URL, create the movie nodes using merge with the movie ID field as a unique identifier, and set the following properties on the movie nodes. Great. Okay, and again, GraphAcademy is helping us out by saying, well, this is what you did with the person nodes. Okay, so I'm going to say load CSV with headers, because when we saw in our file, that was definitely what we needed. I've just copied that URL. So load CSV with headers from there. I need to give it an alias as a row. And you know what? Let's just, because oh no, what have I done wrong here? Oh, I've missed from it. From. Test as we go along. Great. Okay. My Cypher works. Any point I can press the up arrow to kind of get my Cypher back. Great. So first thing I'm going to do is I'm going to say, okay, well, I'm going to merge. I'm going to merge a movie node in. And it tells me that use merge with the movie ID field as the unique identifier. Okay, so set movie ID. And again, I can actually, let's just check, are movie IDs numbers? They are. Okay, that's good. Let's use 2 integer then. And I'm going to say, okay, well, that's going to be equal to row.movie ID, because that is what's being pulled from the CSV file. Okay, well, that's good. Okay, then set the following properties on movie nodes. All right, set. So I'm going to set M, because that M is the variable name that I've given to the node that I've just created. TMDB ID equals row dot TMDB ID. TMDB ID. Great. Yeah, and then I can kind of do the same thing for all of the other nodes. Other thing I'm just going to look at is I should probably be setting TMDB ID and the IMDB ID to be integers, but I will just have a quick look in my CSV file. Movie movie TMD BID. Okay, great. Yeah, okay. So rather than have to go through the whole of me typing this out, let's do a bit of cut and paste. So set TMD BID to be the row.tmd BID, IMDb to be IMDb, released, title, row, plot, budget, etc. And that looks, I think that's right. Let's give it a run. Okay, so I gave it a run. I ran it. It added 93 labels, created 93 nodes, set 744 properties, and completed. Okay, so that suggests to me that I have created my nodes. Let's check them. So let's run this simple match clause to check them. Yeah, that kind of looks okay to me. Each node, I've got some databases. I've got some nodes. I've got some movie nodes, and they've got data in them, which is what I expected to happen. Yeah, that looks pretty good to me. And one of the things that we can do with GraphAcademy is after we've completed one of our challenges, we can use the kind of check database. And what check database is going to do is it's actually going to check the sandbox that I've just used to say, actually, have you completed this challenge? And ultimately, what it's doing is it's saying, are there any movie nodes within the sandbox? In which case there is. I've just noted a comment from getting the above error.
Yeah, so it seems same error that Peter gets with the null property value for movie ID.
Oh, okay.
It's,
I'm gonna. I mean, if
strange.
Yeah.
Movie ID was the one at the very beginning, so that we're basically counting the rows.
Yeah. Let's so I'll leave my, but I think the things that I would check is make sure that movie ID has been spelled correctly. It will be case sensitive as well. So there's a capital I.
Yeah.
Because we've set up the constraint on the movie node, it won't let us create a movie node without that movie ID. So if we have spelt the property incorrectly, maybe with a lowercase I, that would certainly affect it. But also, if we were to, when running this Cypher, I don't know. So I'm just going to have a go. I've used two integer with movie ID. So it's a lowercase m and an uppercase I.
Yeah.
Which sort of makes sense to me, because what that's going to do is if I run that, okay, great, I get the same error. Again, it's because when I try and pull movie with a capital M and a capital I from the CSV file, it doesn't exist because it's case sensitive. It's a lowercase m and an uppercase I, like that.
Yeah. Then it cannot find it, and then it obviously throws the error.
Yeah. Great. Okay.
Peter
Hopefully that solved your problem.
Yeah, exactly. Yeah. Peter, maybe check your spelling as well. I mean, I see it looks like you spelled it correct. Well, this is the error. So check if you write the code, the Cypher statement in the same way. Then Martin just showed here. Then you should be good. Hopefully.
Yeah. Great. Okay. I'm going to move on to the next lesson, which is about relationships. So let's recap where we are. So we have created both person and movie nodes. and we're going to learn how to create relationships based on data within a CSV file. Now, in this case, we have got a CSV file called actedin.csv, and again, let's have a look at it. And if we look at acted.csv, we can see that it has got a movie ID, a person TMDB ID, and a role. So in this case, movie ID represents the movie that this person acted in and played this role. Yep. So we're going to create a relationship called acted in between the person and movie nodes. So to do that, we're going to have to use load CSV to load that data from that acted in CSV file to match the relevant person and movie nodes, and then use merge to create the acted in relationship between the matched person and movie nodes. So if we just have a quick look at this Cypher, let's see if we can kind of work out what it does. Again, we're seeing the same old load CSV with headers from this URL. We're calling it row, and we're going to match the person node. So we're going to say, find me a person node that has a TMDB ID that matches the person underscore TMDB ID that I get from the CSV file. So I'm going to match a person node. I'm going to match a movie node. And then what I'm going to do is I'm going to use P, so the variable for the person node I've matched, and M, the variable for the movie node I've matched, and I'm going to create or merge an acted in relationship between those two nodes. And then finally, what I'm going to do, I'm going to use that relationship, and I'm going to set the role to be the role that person played or acted in that movie, which I get from the CSV file. Let's just go back over that. I've got two match clauses. So I find the person, I find the movie, I then create the relationship using merge, and I then set the role property on the relationship that has just been created. Okay, so let's run it and see what happens. So again, GraphAcademy has kind of pre-populated this query into Sandbox for me, so I can just run it. And again, we can see it has created 372 properties, 372 relationships. So let's just have a go. Okay, so to verify that we've created this acted in relationship, we can just use it. So here's again a simple match clause that finds person nodes, finds acted in relationships, and find movie nodes, and just returns the first 25. Again, what we should see now is that we have movies that are connected through relationships to the two person nodes, and there is an acted in relationship. So in this case, this is Father of the Bride Part 2, and we've got a person, Martin Short, who acted as the role of Frank Edelhofer. There we go. So we have taken a file called actedin.csv, which had IDs that linked together person and movie nodes and told us who'd acted in what movies. We've run that and we have created them. Again, we've got a quick question about creating relationships. So which Cypher clause would you use to create a relationship? We've been using merge. So I'm still waiting for the one I get wrong. Great. So let's move on to the next lesson, which is about a directed relationship. Again, this is a challenge. So to complete this challenge, you will need to create the directed relationships between the person and movie nodes. So what we need to do is we need to write a Cypher statement to create the directed relationship between the person and movie nodes. The directed.csv file, again, let's have a look at it, contains just movie ID and person.dib TMDB IDs. Okay, so we've got a CSV file that's got just movie nodes and person TMDB ID nodes. So let's do this. Okay, so we're going to say load CSV with headers. Headers from. We need that URL. So let's get that URL of that directed file. Oh yeah, we need to give it an alias. So let's give it as row. I'm going to do return row because let's just make sure. Okay, great. We've got the data back that we need. So in order to do this, I need to match a person node. I need to match a person node. So I'm going to say, what person node do I need to match? Person TMDB. So it's the TMDB ID. And I need to match that based on the person underscore TMDB ID record in the CSV file. And you know what? I'm just gonna. I'm feeling slightly paranoid, so I'm just gonna run it. Oh. So what I wanted to do is I just wanted to actually just test, just to make sure that actually I was returning the rows that I was expected to, but it's not. So I've obviously done something wrong. I'm just actually, if I just kind of, I'm pretty sure I know what I've done wrong now. So again, as we saw in kind of previous lessons, GraphAcademy has given me the Cypher that we use to create the acted in relationship, and I've just noticed that I haven't converted the data that I get at the CSV file, which will be a string, to integers. So let's see if I get rows back now. Now I get rows back. Okay, great. Okay, so what I've done here is I've loaded all of those IDs from that directed CSV file. I've matched the person. I've just returned the person. The only reason I'm doing it is just to kind of test that my code works. So once I've got a person, I need a movie. So I'm going to match a movie, and this is done on movie ID. Yeah, movie ID. Movie ID. And again, I need to use to integer because movie ID is an int. I say return p. Again, let's just do that. Do I get data back? Yeah, I get lots of it back. That's good. Right. So that's not what I wanted to do. I didn't really want to return this data. What I wanted to do was use merge to create a directed relationship between the person that directed the movie. So I'm going to use merge. So the person, and I'm going to create that relationship directed from the person to the movie. Yeah. There's any way to find out if this works, right? Let's just give it a run. Okay, so I've created 99 relationships. I vaguely remember that there was 99 movies, so maybe that is right. So to verify you've created a directed relationship section, run the following Cypher. So if I run the following Cypher, great. Okay, so I have got directed relationships. I've got the movie Casino was directed by Martin Scorsese. Great. Okay. Oh, this is interesting. Okay, once you've created acted in and directed relationships, you can use it to find people who've acted and directed in the same movie. That's sort of quite good fun. What have we got here? Mighty Aphrodite. Woody Allen directed and acted in. Who knew? And again, once we've completed our challenge, we can then check the database, check the sandbox, just to kind of, and GraphAcademy will go off and actually make sure that that we have done what we said we were going to do. Okay. So let's kind of recap where we are. What we've done is we have learned how to load a CSV file from a URL into Neo4j. We've also learned how to use that data within match and merge clauses to find data, and to then use that data to create nodes and relationships and properties. And we've got a quiz to do. Right, let's run through this quiz and then we'll take a break and we'll have a chat about anything that we might want to talk about. So review the following CSV data files and answer some questions. Okay, so I've got what looks like airports. Okay, I'm using a pipe terminator, and I've got some flights, which look like they correspond to airport codes that I've got above. Okay, and this one uses a okay, so select the correct syntax to load the data from the airports.csv file. Okay, I'm pretty sure it had headers. Didn't it have headers? It has got headers, and it uses a pipe. So CSV with headers from their field terminator pipe. Creating relationships. The flight CSV file contains data about flights. That's good. Select the correct Cypher statement to add the airline property to the relationship. So what's this doing? This is using that flights data to match an airport, departure airport, and an arrival airport. So I get an A node, a node, and a D node. So departure, that creates the relationship as F. So set. Well, I want to set the airline to the relationship. So set f.airline. Road airline. Nice. The airport code property is unique. Select the correct Cypher statement to create the constraint. Ooh, okay. I'm pretty sure. So it's airport code. So I'm pretty sure that's the correct syntax. Why have a unique property? So make sure that duplicate data is not created. Yeah. It doesn't improve. It doesn't help you accidentally deleting stuff, and it doesn't improve performance. That would be indexes. So I think that's good. Nice. Right. I'm genuinely very, very pleased that I haven't got any of these wrong yet.
Well done.
Yeah. So I think we're sort of getting towards end of time, aren't we?
Kind of, yeah. We are close to that. So again, if you have any questions on the course for Martin, generally on GraphAcademy or Neo4j, then this would be a good time to post them in chat right now. If you are struggling with any other courses during the time, if you watch this later on, then there is a Neo4j community page. There's the Neo4j Discord, which you can use to get in touch with the community, to talk to us, to raise problems, but also to, if you're struggling with something, if something is unclear, then you can find these segues to get in touch with us on all things GraphAcademy.
Yeah, and it's been while people are potentially thinking of questions, it's been really helpful for me. One of the things I'm going to change about the courses, I'm going to put some hints and some tips in about just reminding people about case sensitivity, which is something that I shouldn't have overlooked, because it's a common problem that lots of people face. Just to talk about the kind of rest of the course. So the course is made up of 4 modules. We've done the first 2. And interestingly, it's a 2-hour course, and it's taken us an hour to do the first 2. So that's about right. The other 2 modules, one is on data types, lists and labels. So again, modifying the Cypher that we've started to create during this course to add correct data types, to use lists, to kind of use list values as well for things like languages, and which are kind of like super helpful. And then the second module is around importing data considerations. So we've talked about one process for importing data, which is about using Cypher to import data. The last module talks about other options that might exist. Somebody talks about the Neo4j admin tool. Again, doesn't go into great detail, but it talks about that as being an option and what the kind of benefits are of using that, or maybe an ETL tool, or maybe actually writing your own import process using drivers. The last module also talks about things like how to manage transactions. So if you've got very big files, how to kind of split that up into transactions, and also how to avoid things like the eager operator, which can be kind of very memory intensive, particularly if you have big imports.
Cool. Yeah, there was a comment earlier on APOC periodic iterate that somebody's using a lot to load and to read CSV files. I guess that's something that the later in the part of the module this would have been covered, or at least maybe the documentation covers that. So that's, it's a fundamentals course. So APOC is considered a little bit more of a advanced usage scenario, but good that you're using it. There are lots of opportunities and ways of getting the data into a graph.
Yeah, Stefan raises a really interesting point, which I am going to go back and look at because I think Stefan might be right. So again,
Comment was constraint improving performance. I think a unique constraint creates an index in the backend and will improve performance. Just on the case of the import, that probably is true. Yeah.
Yeah, I just want to. I just want to check that. And perhaps poor choice of words or kind of like options on that kind of last multiple choice question we looked at from me. But yeah, thank you for that.
Yeah. Very cool. Thank you very much. So as I said in the beginning, this was a test, or this is a test. This is a new format kind of which we're trying out. So if you like this, if you think this is interesting, then please go on YouTube and give it a thumbs up, give it a like. Potentially also write your comments in the comment segment there, or on the community forum, but preferably I think YouTube would be the best way. Or when you watch it on LinkedIn or some, or Twitter, X, then comment there as well, and let us know if you like the format. So we will continue doing it, and with different course. Maybe you let us know which course you'd like to run through together as a team. Then we would have some kind of inspiration for that as well. That would be great to hear. And if you are looking for more content in general on the Graph Academy, please go check it out. I'll post a link again in where is it, here in the channel chat. It's very easy. Graph Academy on the Neo4j pages. Lots of trainings, lots of courses. Check them out. And if you are eager for more live streams, then I'll be back on this Thursday, 25th of January, same time, on a Neo4j live recap. Well, recap is not the right word. It's a catch up with notes, basically. One of the submissions we didn't accept for notes because of capacity, basically. But Astrid Krickel will join me to talk about building a semantics-based recommender system for ESG documents. ESG is this sustainability effort by the United Nations. So I think this should be interesting, should be fun. So if you're interested in that, join me on Thursday. And come over to the community page, come over to Discord for any question, anything else. And thank you very much, Martin, for joining today, for presenting, and for guiding through the CSV importing course.
Thank you.
All right. Well then, take care, everybody. See you next time, and